I wanted to talk about how our practical experiences, really implementation, both in combination of my, unfortunately, 20 plus years of playing with perfusion, both CT and MR, starting with Dr. Osgood's software literally in the late 1990s, followed by watching it evolve at UNC over the decades, and unfortunately are not being responsible for it. Let's see, I'm on the advisory board. My own research interest is actually quite diverse, but we do a lot of work in sort of exploring this functional CTA side of things. We have developed some whole brain perfusion analysis, and then have some old work comparing DSC-based CBV and DCE CBV. It's funny, nobody talks about this anymore, it seems like, and I've spent the first part of my career trying to explore it. So our experience at UNC with CT perfusion for stroke is actually a little bit unique. We have a very famous, now retired neurologist, whom you all know, but I won't mention right now, who the day that this was presented at the European Stroke Organization, he calls me and says, okay, we need CT perfusion. The patient the day before didn't need it, but the patient the day after did. And so I scrambled immediately to try to develop a technique that we could deploy internally to calculate CT perfusion maps so that we could have core and penumbra. We had our scanner vendors had perfusion post-processing, but of course we didn't have the core and perfusion calculations, so we rigged up this ridiculous pathway so that the neurologist could calculate these things. But within 24 hours, we could start generating ischemic core and penumbra maps based on Tmax and CBF. It's brutal what we had to do to get there. And then we spent the next 2 years, that's how things happen when in a university system, before we actually got a real software package that could do it automatically. So there's a lot of hurry up and wait during this time. And we had this first deployment, I'll just call it vendor 1 for now. Over the last 6 years of deployment, overall, no major issues, except for when I go on vacation, apparently. We had a couple of network failures, always when I go on vacation. I'm answering it. Thankfully, they are responsive, and so I was able to get them fixed and the system back up and running and me back to my vacation. One huge error that occurred just a couple months ago, which I will raise as a major issue if you're going to do this, and especially to vendors who are paying attention or you're working with vendors, is we had test cases sent at the exact same time as a clinical case. The neurologist didn't recognize it. I happened to be around. I wasn't on service. I was looking at it going, that doesn't look like our normal CT perfusion image. Something's not quite right. I spent the next half an hour digging into it, and it turns out a test case was sent to test our communication system. And the neurologist interpreted that as the patient who was on the table. Of course, it was a male, not a female. The ages were actually pretty close. So things that, things to watch out for if you're thinking about it, right? The mistake that never should happen, well, thankfully it didn't change care, but it did happen to us. So more recently, again, I'm responsible for the neuroimaging across our main hospital. That's 7 scanners, I think, and definitely the acute stroke center, the main hub, if you will, for the University of North Carolina system. October, now a year and a half ago, a new perfusion vendor a request was initiated by one of our NIR faculty. The main reason was this patient care coordination feature that they wanted. They desperately wanted this. Our primary vendor didn't have it, so they said, oh, we should explore the second vendor, and so on we started. Dozens of team members are involved in this process. It's across 5 physical hospitals, us as the main hub, and all the hub and spoke centers are participating. I actually wasn't involved initially. Finally, somebody got around to saying, hey, you need a neuroradiologist who's going to be responsible for the protocol and making sure everything's working. So I got dragged into this a couple months later. Long story short, that's actually how we got introduced. So the perfusion software, the CT perfusion software, was from the other vendor, and because they didn't have an MR solution, we were introduced to CirCare at that point in time. I had actually watched for about a decade already, knowing that some of the capabilities that might be there, and so there's particular interest, but this is the first formal introduction. Mid-April 24, finally the trial went live. Almost immediately, I paused that trial. First of all, the first images that came across for the LVO detection, the residents couldn't see the LVO because of the DICOM structure and how it was passed along. There was poor PACS integration, so the residents, unbeknownst to me, immediately stopped the LVO portion of the trial, telling our IIT people, stop it, we can't tell what's going on. I found out about that 2 weeks later, and then started having major concerns with the perfusion maps. Again, this is a different vendor. We'll call them vendor 2, and there's marked discrepancy between vendor 1 and vendor 2. As now the person responsible for this trial, I started communications with vendor 2 and saying, hey, what are we doing? What are we doing wrong? Et cetera, et cetera. Long story short, after 2 more software iterations, this is FDA-approved software. This is FDA-approved software that we're working with. I halted the trial. I was sick of trying to be their sort of fix-it and beta tester. And unfortunately, if you count the number of man-hours in this test, it's obscene across literally 5 separate hospitals, my own time in this process. Needless to say, I was not a very happy camper that I spent this much time trying to get something to a point where I'd be comfortable actually testing, using it on patients, and I don't feel we ever got there. But that also gave us our introduction to CerCare, so I can't completely complain. Just as a reference, just as an example, here's vendor 1. Vendor 2 is the one that we were exploring. You know, I don't think anybody needs any education here to sort of say why I was concerned. Some beautiful ventriculograms, if you will, but obviously not very useful for us clinically. It seems amusing, but of course, if your clinicians aren't looking at the images, right, the trainees aren't, and they just glance at the numbers and report these numbers, who knows what's going on? So this is a major concern when we have automated software, and why I spent, therefore, a lot of energy looking at this. This is just, for example, what we did early on, comparing vendor 1 and vendor 2, calling vendor 1 the reference, vendor 2, looking at our core volumes and penumbra volumes. You can see the R-squared values were all over the map here. The penumbra volumes were a lot closer, but if you actually dig into this, there are some concerning sort of variables. So I would strongly suggest, especially if you have an existing vendor and you're comparing to anything new, it doesn't matter what the story is, but you do want to take a careful look and work through it. It seems obvious, but I also want to train our residents and the future fellows to make sure that they're thinking about this and the appropriate ways to analyze this data. For those who've been around the block a couple times, that's one of the reasons why, you know, MR perfusion, if you hear the old stories, why we didn't succeed the first time around. So just some lessons learned with vendor 2 that you might take, be you a vendor or be you a end user. Please don't let the MDs be the alpha or beta testers. I have the technical background to sort of explore it, but you know, I did this because the rest of my section was not interested in doing this. And unfortunately, if we were going to evaluate this as a hospital system, we needed to take a close look at this. Our technologists in IT are not sufficiently familiar with our needs. I mean, it seems obvious for me to say it out loud, but they simply aren't. I have multiple stories about our technologists making perfusion maps look correct just to make us happy, but fixing things that didn't need to be fixed or taking alternate routes that didn't make sense. And so, unfortunately, you have to have that technical knowledge, and you really have to make sure that everything's working the way you expect with that technology. Integration with PACS, I purposely avoided being on the PACS integration side of things in the general sense, only because I have enough research responsibility, but it has to be seamless, right? If it messes up your workflow, if you're residents or you can't see the LVO because you're re-windowing to be able to see the CTA correctly, that's a problem. And so we found this out very quickly, like I said, as an example, but I found that if this integration is not seamless, right, if it causes us half a delay, especially with our busy workflows, it's not going to be accepted no matter what. And so I think that's another critical issue. Depends on your PACS, depends on, of course, what software you're talking about, but that was critically important for us. And of course, MD shouldn't be beta testing the workflow integration either, right? We went through months of that discussion of how we're going to deploy this, which pathway, what is a DICOM RT versus a DICOM struct, and all those things. But there was clearly the two vendors weren't talking to each other effectively, and it kept on, messages had to be passed through me to sort of pass the message back. And I quickly got sick of that. And nobody in this room probably wants that responsibility from the clinical side. The clinical and tech support must be readily accessible. I had a lot of problems with vendor 2, constantly saying, hey, this is wrong. I mean, I was, at that point in time, I was talking to their CTO on a weekly basis. basis. And the problem is he's the CTO. He doesn't understand what's going on at that level. He might be able to ask somebody else to solve it. But I didn't have that moment-to-moment support from vendor 2, and it was quite painful in that respect. Anyways, moving on. Because I had this old data that I was sitting on, we decided to reprocess with CTP. I'm not trying to say anything with this. The core volumes here, at least I'm getting much better R-square values when I just compare the CircCare post-processing from vendor 1 as a reference. These two outliers, what seem to be outliers, are likely patients who had prior infarcts. And so we want to look into, if we were going to deploy CT perfusion for this sake, I want to look into this more carefully to understand what's going on. And the penumbra volumes are getting at least decent R-squared values, especially, this is just a small set that I happen to have with both sets of software. And it'd be interesting to, well, mildly interesting to do a three-way comparison, but I don't think there's any specific need to. So in the last year, have spent a lot of time with deploying the CircCare software through 3 separate mechanisms. Initially, through Tira Recon and their Eureka AI product, then through Singovia, and now also through a direct server. And so I've gotten to know the software, especially as its workflow is seen through the eyes of 3 literally different directions. I've been impressed. The system configuration is incredibly flexible. I would make the suggestion, and some people know that pre-configured stroke and tumor workflows may be useful, but bottom line is the flexibility has allowed me to do things. And you'll see, I think I'm the only person who's going to present in both stroke and GBM domains, and I'll talk about the GBM in a second. The outputs are mature. I will say the first version, the first image that I got had an error on it. I sent it back and they said, oh, it's already fixed. And immediately they sent me the next version, and that was fixed already. So that's responsive technicals, people who are actively developing. And in my sort of day-to-day workflow in this environment, I never saw majorly concerning, unlike the other image I showed you, outputs. And so that was very, very reassuring from my perspective. Edge cases still have discrepancies. I'm okay with that. And then, you know, the big question that I have, which I haven't even begun to fully explore, is how do we handle, and I don't know that we know as a field, how do we handle prior infarcts in patients with significant other vascular disease? I will say, the technologists and technical support have been incredible. Maybe it's because we're fortunate to have Shannon and Aurelia responding to us quickly, but poor Shannon has been answering my emails whenever, and especially because I've had fast turnaround deadlines to sort of look at things. So I have been very impressed. Of course, that's because we're in the U.S., and I guess Shannon's in the U.S. at least, but I've been very fortunate to have that level of technical support. And this is at all levels, like, you know, everything from, geez, how do I configure this setting, or the regular expressions to define my outputs or whatever, or inputs to the files, to the system. Switching. My interest, obviously, we have both stroke and GBM, and I play an active role on the tumor board on the GBM side of things. We, having been at UNC and been literally responsible for the perfusion analysis at UNC since I was in graduate school, literally the perfusion sequence at UNC for a decade was named Yueh Lee perfusion. So if you ever got a scan from us and wondered who RAY_LEE was, well, that's me, and it's because I put it in place. So I've been following this and responsible for decades. Today, we officially use the vendor-provided perfusion pipeline. We literally have 4 separate versions across our systems. We have the original Leo. If anybody's old enough to know what the Leo is, we still have that. We still use that for certain workstations. We have 2 or 3 automated ones which produce different results, and one of these, the techs fooled because some data wasn't flowing in correctly. It gave them an error, so they delete the sequence and they do something. I fully don't understand what they do, and I'm pretty sure the maps are wrong. So this is a huge issue across our system when we have 8 to 12, I don't even know how many scanners we have. I think 8 to 12, depending on where the data is coming from. So there's a lot of discrepancy, and I don't know how to interpret that when I get the brain tumor board, when it's literally, I have an example case, I don't show it here, where I have 4 separate panels from 4 separate dates and 4 separate scanners and 4 separate perfusion pipelines. That's how crazy it is at our institution because we have so many generations of scanners. So we desperately need normalization, which is why I was interested in looking at CirCare for our perfusion data. So for fun and really just to get a feeling for this data, we did a preliminary retrospective analysis. I went back to 2020 and looked at GBM patients with perfusion data that's available. I've learned all the different ways you can mishandle storing the data in our packs or not storing it, but I was able to find at least quickly scrolling through there, and this has been in the last 2 months, I found 15 patients with available data that I've punched through the software. And I wanted to do very simple image analysis using the CirCare, the software interface, draw ROIs similar to some of the work that was presented earlier. I drew a simple contralateral white matter temporal region control, and then 2 more ROIs on the enhancing lesion whenever possible. This is all comers, patients, high-grade gliomas with that we had perfusion data available. Just some sample maps. You've seen enough of them today. I'm not going to belabor them. We have our standard sort of outputs. This is the corrected CBV, CTH, and then the leakage, which I thought would be interesting to at least explore given the amount of time I'd spent previously on DCE based. Here's a different patient just with a much more aggressive appearing lesion with elevated CTH and leakage. So to get at the sort of question that was earlier about thresholds, I took a slightly different approach, and my statistician also forced me into that approach, which is literally I just manually calculated survival of the patient by looking at right, this is 2020, so I had plenty of survival data. We looked at survival versus corrected CBV, plotted it on the chart, and then CTH, because I was very interested in how CTH played a role in this. Clearly, as no surprise to probably anybody, especially given the other talks, CBV obviously is associated. You can sort of see that curve. I didn't try to put a curve through this, is associated with CBV. CTH has an interesting sort of pattern. You can see that it's seemingly semi-random, but there's clearly a population of patients that have a special relationship to that. So I asked my statistician, hey, how do I analyze this? He gave me regression tree analysis. I tried to nudge him toward the other methods. He's like, no, the only thing I can do is regression tree analysis. And so long story short, as we plug in the values of CBV to simply try to predict progression, and again, this is all comers, so there's nothing special here. CBV plays a dominant role here, but there's clearly a CTH signal in this data. That's not much of a pipeline, 15 patients, but in terms of a first pass analysis from just UNC old data, I can clearly see that there's a CTH signal in this. And based on the, sort of nice to be the last one presenting, because based on everything that everybody else has said, especially in the tumor space, there's most likely a CTH signal. And so I think we're particularly interested in exploring that and digging deeper. So early conclusions from our local data, and this is roughly, you're seeing about 2 months worth of me, right, in my quote unquote spare time, punching through this data and trying to understand what CirCare can do in my off time. Some of this is sitting on a laptop that's on my desk at home. My wife has no idea why I have a gaming laptop on my desk at home, but that's why. Clearly, RCBV, through the normalization of pipeline, we're seeing that signal. CTH, we can see that potential signal. I think if you go back to the original published work, there's some fascinating conversations about bevacizumab and that story. My study limitations, obviously, n equals 15 is very small, all comers. I completely ignored treatment status. I completely ignored Bev status. And we actually, newer data we have in the CAR T space, that's a whole long story in and of itself. We're trying to explore that and trying to understand that looking forward. So very simplistic analysis, but clearly the fact that we have a nice automated pipeline that I can homogenize across my fleet of scanners. Obviously, I'm interested in real progression versus pseudoprogression, and then this predicting treatment response, especially this vascular normalization. It's alluded to in the rat data that's published, and I apologize, I don't remember the year of the paper, but our neuro-oncologists were all over this when I presented this data to them. There's clearly a signal, I think, that the Bev story, the bevacizumab story, that's underexplored and barely, and the more sophisticated neuro-oncologists, at least at my institution and that institution down the street, which will go unnamed because they're doing better than us in basketball this year, they got excited about that story. So I do think there's a story there that's worth pursuing for those who might be doing different Bev doses, et cetera. Thank you. That's Chapel Hill. Not that anybody ever comes and visit in North Carolina. Feel free to email me if you have any questions about the workflow and sort of my experience. Thank you.
Thank you so much for an exciting. So I guess success is measured on how good your summer vacation is this year. Questions? Um, so if you were to give someone advice who is buying new software, we basically saw it here is that to be very practical about it has to make sense, it has to work, and uh, and then it also has to get clinicians and scientists excited when they see the images and then have this feeling that they can learn something new. Um, I, we heard neuroprotection being mentioned again before, and also vascular normalization. Understand how is it that tumors get the right amount of oxygen for the various treatments to be efficient. There's lots to be learned there.
Absolutely. And I think that's the critical, and again, it's your paper that's almost a decade old at this point in time, but I think that's the key story. I mean, given uh, the story to me in the tumor space, that's the most interesting, that's I think understudied, is that because I think we missed incidental, there's incidental data out there, sort of commentary that BEV at different doses is critically important.
Right.
You nailed that one graph, and when I showed that, I had a gasp from multiple oncologists in the audience who got it, who immediately understood.
Oh, wow.
Right. So, I mean, the power of that one graph, and I think if you get that story correct, so I do think there's a story there. Number one, on the stroke side of things, as presented, and is I think there's clearly a story there also. And I played my PhD was MROEF the first time around, and all this. So I've been in this field long enough to sort of see that we've tried multiple attempts, and I think quite practically, the story still needs to be validated, but I think we have a clear potential for a story here, and it's really a question of having sufficient data. And I'm as a person who's been wholly centered in the US, it's incredibly impressive the amount of work using very different protocols, very different approaches, MR accessibility, et cetera, that's happening in Europe. We're a CT perfusion shop, primarily MR in extreme cases only, even though I'd love to be the other way around. But I think the potential is there, and I think having a platform that's stable and homogeneous helps us get away from, everybody's little ROI being slightly different.
Thank you so much for sharing your data and your
Thank you.
experience.